In the last lesson, we noticed that things, nuclei, unstable nuclei will decay. There's three major ways that radioactive decay occurs, and those are named for the particles or rays that are involved. So alpha decay is named alpha, and we symbolize it with the Greek letter alpha, and this is actually a helium-4 nucleus. So He42, right? So it's 2 protons and 2 neutrons. Beta decay, this is the Greek letter beta. This one involves neutrons, and that neutron either changes into a proton or a proton changes into a neutron, and so there's another particle emitted from here. This is either going to involve an electron or a positron. And then there's gamma decay. Gamma decay, there's the Greek letter gamma. This one only involves energy. This one is a strict energy thing. There's no particles emitted from the nucleus. So it gives up some mass that's released as energy, but the number of particles don't actually change. Now, in alpha decay, an atom emits an alpha particle, which I said, 2 protons and 2 neutrons, a helium nucleus. So here we have polonium decays. That's what that arrow indicates, right? So in a chemical reaction, we say reacts. In a nuclear decay, this decays. So polonium decays into lead and helium. Pretty straightforward, and we're going to see that we can actually keep track of all the protons and all the neutrons, because whatever this started with protons and neutrons has to be over here. They have to sum to what we started with. We're still not destroying particles, we are just keeping track of the protons and neutrons and where they're at. So when we write these in isotope notation, we start with say polonium, and 84 is its atomic number, and let's just say we had 170. I don't know what it is really. We know we're going to end with helium. That's this alpha particle, helium-4 Now what we have to know is the mass numbers on the left have to equal the mass numbers on the right. So if there's 170 on the left, we need 170 on the right. 4 of them are right here. That leaves 166 to be here. There's 2 protons here. We started with 84, so we need 82, right? 82 plus 2 gets me 84. And then I can see that the 82nd element is actually lead. So this is lead 166. Now, that is alpha decay. The protons plus protons on the right equals the protons on the left. The mass number plus mass number on the right equals the mass number on the left. That will always be the case. So here's an example. Lithium-11 is an unstable isotope of lithium that undergoes alpha decay. So we write the equation. So we start with lithium, and it's lithium-11, and we look at the periodic table. We see lithium has 3 protons. Lithium decays into something and an alpha particle. So I'm going to go ahead and write my alpha particle, helium-4 and then I'm going to subtract, right? 11 minus 4 is 7. 3 minus 2 is 1, and I find that the element that has 1 proton is hydrogen. This would also continue to decay, by the way. Hydrogen with 7 neutrons is going to also be very radioactive. And then it says write the equation and draw a model of this alpha decay using different colors to represent protons and neutrons. So lithium-11 has 1, 2, 3 protons, and then hydrogen has 1 proton, helium has 2 protons, and then I can grab another color and I can draw in all of my neutrons. So I've got 8 of these because 11 minus 3 is 8. Here I've got 6 of these because 7 minus 1 is 6. So 1, 2, 3, 4, 5, 6. And here I've got 2 of these because 4 minus 2 is 2. And what I can see is my mass numbers all work. There's 4 things, that's 4. Here's 7 things, that's 7. Here's 11 things, that's 11. 7, 8 neutrons. Did I have 8 neutrons over here? I should have. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so 8 neutrons, 8 neutrons. And then my protons are also the same. 1, 2, 3 protons, 1, 2, 3 protons. So when we have alpha decay, the number of protons and neutrons doesn't change, but the number of atoms does. We always start with 1 atom and end with 2. We end with whatever it decays into, and the alpha particle, the helium atom. Okay. Uranium-238 undergoes alpha decay. Write an equation of the process. So we find uranium on the periodic table. Uranium is element number 92, so it has 92 protons. It undergoes alpha decay. You can write your alpha particle first if you want. So this is 4, 2. 238 minus 4 is 234. And 92 minus 2 is 90. And so we find element 90, and element 90 is thorium. There it is. An unknown atom undergoes alpha decay. Uh-oh. So I'm going to draw my arrow. It undergoes alpha decay. Over here, I have helium 42. That's what alpha decay means. We get an alpha particle out of it. The atom that is produced is radium-228. So Ra228. And then I find radium on the periodic table. Radium is element 88. And now all I have to do is add my protons over. That's 90. And my mass numbers, that's 232. So 90 is, of course, still thorium.